In this video, we will continue musculoskeletal system. We will cover bone tissue. A bone is a complex structure shaped for its particular position in the skeleton and the stress it has to bear. Bone tissue, also known as osseous tissue. It is a specialized connective tissue that is mineralized and has an intercellular honeycomb-like matrix which helps to give the bone rigidity. Bone tissue is made up of different types of bone cells. Osteoblasts and osteocytes, they are the bone formation and mineralization cells. Osteoclasts, they are bone resorption cell. Modified or flattened osteoblasts, that is bone lining cells that form a protective layer on the bone surface. The mineralized matrix of a bone tissue has an organic component of mainly ossein, a form of collagen, and an inorganic component of bone mineral made up of various salts. Bone tissue is classified as combat or cortical bone and cancellous or trabecular or spongy bone and depends on how the bone matrix and the cells are organized. Although bones may also contain other kinds of tissue including bone marrow, endosteum, periosteum, nerves, blood vessels and cartilage. The amount of a cortical or trabecular tissue is dependent upon the function of the bone. The hard outer layer of bone is composed of a cortical bone, which is also called compact bone, as it is much denser than cancellous bone. The cortical bone gives bone its smooth, white and solid appearance and accounts for 80% of the total bone mass of an adult human skeleton. It facilitates bone's main functions to support the whole body, to protect organs, to provide levers for movement and to store and release chemical elements, mainly calcium. Cortical bone is covered by a periosteum on its outer surface and an endosteum on its inner surface. The endosteum is the boundary between the cortical bone and the cancellous bone. The primary anatomical and functional unit of cortical bone is an osteon. The compact bone forms an outer layer to all bones and most of the structure of long bones. It provides few spaces and offers protection and support to the bones as well as helping the long bones to bear the weight of the stress placed on them by body weight and is thickest in those places that receive the greatest stress. Its dense texture gives strength to the bone but makes it heavy. To the naked eye, compact bone appears solid, but on a microscopic examination, large number of Hawaiian system or osteons are seen. It consists of multiple microscopic columns, each called an osteon or Hawaiian system. Each column is multiple layer of osteoblasts and osteocytes around a central canal called the osteonic or Hawaiian canal. The columns are metabolically active, and as bone is reabsorbed and created, the nature and location of cells within the osteon will change. Compact bones have a central canal that helps to make up cylinder-shaped osteons or Hawaiian system. The osteon is the basic unit of structure of a compact bone comprising a Hawaiian canal. Hawaiian canal containing blood vessels, lymph vessels and nerves surrounded by concentrically arranged rings or plates of bones called lamellae. Between these are lacunae, tiny spaces containing tissue fluid and spider-shaped osteocytes that is called mature bone cells. At the junction of the lamellae are spider-shaped osteocytes occupying the lacunae. The tissue fluid nourishes the bone cells. Lacunae are small cavities that house mature bone cells called osteocytes. These osteocytes are connected to each other and to the bone surface through tiny canals called canaliculae, which allows them to receive nutrients and respond to mechanical signals, playing a crucial role in bone maintenance and repair. Thin hair-like canaliculae connect lacunae to each other and to the central Hawaiian canal. The tubular arrangements of lamellae gives bone greater strength than a solid structure of the same size. Bone cells called osteocytes occupy small chambers that is called lacunae that create concentric circles around central canals in bones. Some of the osteoblasts develop into osteocytes, each living within its own small space or lacunae. Osteocytes make contact with the cytoplasmic processes of their counterparts via a network of small transverse canals or canaliculi. Cellular processes passing through canaliculi allow osteocytes to communicate with other cells. This network facilitates the exchange of nutrients and metabolic waste. Collagen fibers in a particular lamella run parallel to each other, but the orientation of collagen fibers within other lamellae is oblique. The collagen fiber density is lowest at the seams between lamellae, accounting for the distinctive microscopic appearance of transverse section of osteons. Osteons or the central canals are connected to each other and the periosteum by oblique channels called Ockmann's canals or perforating canals, which contain larger nerves and blood vessels. The Ockmann's canal lie at the right angles to the long axis of the bone. They are not surrounded by concentric lamellae but are lined with endosteum. The osteons are parallel to the bone's long axis, aid in weight bearing, and are structural units of compact bone. Each osteon consists of a group of hollow tubes of bone matrix that appear like the rings in a tree trunk called lamellae. Each lamella lends its name to the other description of compact bone, which is lamellar bone. The collagen fibers of each lamella run in one direction, whereas those in nearby lamellae run in different directions. This alteration of a collagen fiber placement strengthens compact bone and resists twisting movements. Between collagen fibrils, bone salt crystals are also aligned with directional alterations. Bone tissue is mostly made up of collagen and inorganic salts such as calcium phosphate. Calcium phosphate interacts with the calcium hydroxide to form crystals of hydroxyapatite. These crystals incorporate various calcium salts as well as ions such as fluoride, magnesium, and sodium. During bone formation, the osteoblasts that secrete bone matrix surround blood vessels and stay in contact with each other, as well as nearby osteocytes via projections that extend outward. Each of these extensions contains gap junctions. As the matrix hardens, a system of canaliculi is formed, containing tissue fluid and osteocytes extensions. A mature osteon is then bound together, and both nutrients and waste can move from one osteocyte to the next. The bone matrix therefore allows bone cells to receive nourishment while it still remains hard and impermeable. However, some lamellae in combined bone are not part of complete osteons. The areas between the Hawaiian system contain incomplete interstitial lamellae that either fills gaps or are leftover structures of previous osteons that experienced bone remodeling, remains of older systems partially broken down during remodeling or growth of bone. The interstitial lamellae are the remnants of osteons that were partially resolved during the process of bone remodeling. Near the surface of a combined bone, the lamellae are arranged parallel to the surface. These are called circumferential lamellae. Deep to the periosteum, just superficial to the endosteum, are circumficial lamellae, which extend completely around the diaphysis, helping the long bones to resist twisting. The Hawaiian system forms during the process of endochondral ossification, which starts with the cartilage template that is gradually replaced by bone tissue. Osteoblasts, the bone forming cells, secrete the organic components of a bone matrix that is called osteoid and then initiates its mineralization. As osteoblasts become surrounded by the bone matrix, they differentiate into osteocytes, which reside in the lacunae and maintain bone tissue. The osteocytes connect to each other and the Hawaiian canal via tiny canals called canaliculi. The cancellous bone or spongy bone, also known as trabecular bone, is the internal tissue of the skeletal bone and is an open cell porous network that is composed of a trabeculated bone tissue. Cancellous bone is typically found at the ends of long bones like the femur, near joints, and in the interior of vertebrae, where the bone is actually not solid but is full of holes connected by thin rods and plates of bone tissue. The holes are the intertrabecular space and is occupied by red bone marrow, where all the blood cells are made, as well as fibrous tissue. Even though trabecular bone contains a lot of intertrabecular space, its spatial complexity contributes the maximum strength with minimum mass. It is noted that the form and the structure of a trabecular bone are organized to optimally resist loads imposed by functional activities like jumping, running, and squatting. Cancellous bone has a higher surface area to volume ratio than cortical bone and it is less dense. This makes it weaker and more flexible. The greater surface area also makes it suitable for metabolic activities such as the exchange of calcium ions. Cancelled bone is highly vascular and often contains red bone marrow where hematopoiesis, the production of blood cells, occurs. Thin formations of osteoblasts covered in endosteum create an irregular network of spaces known as trabecular. Within these spaces are bone marrow and hematopoietic stem cells that gives rise to platelets, red blood cells, and white blood cells. Spongy bone or cancellous bone has no osteons. Instead, spongy bone consists of an irregular lattice of thin columns of trabecular. Trabecular marrow is composed of a network of rod and plate-like elements that make the overall organ lighter and allow room for blood vessels and marrow. The primary anatomical and functional unit of a cancellous bone is trabecular. The trabeculae are aligned towards the mechanical load distribution that a bone experiences within long bones such as the femur. Trabecular bone accounts for the remaining 20% of a total bone mass but has nearly 10 times the surface area of a compact bone. To the naked eye, cancellous bone looks like a honeycomb. Microscopic examination reveals a framework formed from trabecular, meaning little beams, which consist of a few lamellae and osteocytes interconnected by canaliculi. The spaces between the trabecular contain a red bone marrow that nourishes the osteocytes. The cells in spongy bones lie inside the trabecular supporting structures of dense tissue and takes the nutrients from diffused substance that enter the canaliculi. The trabeculae are only a few cells thick. They have irregular lamellae and osteocytes interconnected by canaliculi, and no osteons are present. Nutrients reach spongy bones osteocytes via diffusion through the canaliculi from capillaries in the endosteum that surround the trabeculae. Spongy bone gets its name because of the numerous small spaces within it and not because it is soft and sponge-like. It is neither as strong nor as heavy as compact bone because the spaces are filled with the red bone marrow or fat, which gives it a pinkish color. Most bones consist of both compact bone and spongy bone, thus optimizing the balance between strength, rigidity, and weight or mass. Trabecular bone is present in the interior of some bones and resists compression. Within the structure, there are osteocytes playing an important part in sensing local changes in strain. Bones provide the structure for muscles to attach so that we are able to move. Tendons are tough, inelastic bands that hold and attach muscles to bone. In the interior of bones is the bone marrow. Bone marrow is a site for hematopoiesis, the process by which the cellular components of blood are formed. Red bone marrow makes blood cells and yellow marrow stores fat.